All right, good afternoon, everyone, and welcome to the virtual learning course, Writing Out the Stormwater, Sensible Stormwater Solutions for Local Road Projects. My name is Brittany Harlow, and I will be moderating today's session. The session will be provided via both audio and web conference. This program will last approximately 50 minutes, including a Q&A session at the end. If you have a question at any point during today's presentation, you may submit it via the Q&A button on the bottom of your screen. Please note that we will be sending all attendees certificates of completion via email for PDH self-reporting credit purposes. We have a couple great speakers for you today, including Craig Krupp, Brian Copeland, Mike Claude, and Drew Sullivan from Timmons Group. And now it is my pleasure to introduce our first speaker, Craig Krupp. Craig, please take it away.
Thank you, Brittany. We're certainly excited to have the opportunity to talk to everyone today about stormwater management. We have a good list of panelists that are diversified in the transportation industry. So I wanted to take a quick second and make those introductions. We have myself, Craig Krupp. I'm in the Transportation Design Group. We also have Brian Copeland and Drew Sullivan, who are also in our Transportation Design Group, with Drew having a specific focus in stormwater design. And then we also have Mike Claude from our Stormwater Design Group. Together, we have a little over 70 plus years of experience. So we have certainly seen a thing or two, and we're excited to get into our presentation today. From an agenda standpoint, we'll start off with some stormwater management goals, looking at high-level goals, and then we'll move into a more technical discussion on BMP solutions on linear transportation projects, and then we'll wrap it up and take any questions you may have. I did want to remind folks to go ahead and use that Q&A function throughout the presentation. It kind of prevents all the questions coming at the very end. So go ahead and feel free to type in questions as they pop up. For starters, we just wanted to hit on stormwater management goals. The first thing is really knowing and understanding the regulations. We have about 50 folks online right now. We'll probably get a few more as the presentation goes on. So we're dealing with a lot of different jurisdictions today and across several different states. So the regulations, knowing and understanding what the local criteria are very important in determining what the best BMP solution is for your project. We wanted everyone to think outside the box. The BMP solutions we'll go over today are not a one-size-fits-all solution. You may have a certain problem or constraint on your project that lends itself to one BMP solution over the other. So again, we wanted to make sure we think outside the box. And lastly, we want folks not to be afraid to ask questions. We'll be going over a lot of different BMP solutions today, many are which proprietary products. And with those proprietary products come industry-leading experts. So if you ever have a certain constraint on your project or issue or concern, you can let us know. We can reach out to some of those proprietary products and really get their feedback. And we don't want to be afraid to ask the hard questions. And lastly, I just wanted to say that let's check with the entity that is going to have to maintain these facilities. Ultimately, whatever is recommended needs to be acceptable for their program. Getting into the impacts a little bit, we always want to balance our property impacts with the budget and schedule. We know that a lot of these projects we're doing come with grant money or funding that's been obtained by either on a federal level or a state level. And a lot of times those are often have set budgets. So we got to make sure we're protecting those budgets for our clients, and that whatever we're proposing doesn't add any extra costs or anything like that. And lastly, we want to make sure that from a schedule standpoint, we may be looking at traditional BMPs that oftentimes take up a lot of right-of-way and drainage impacts, maybe looking at some alternative innovative ideas that stay within the right-of-way, keeping that in mind so that when you get to right-of-way acquisition, you can actually maybe save some time on schedule. Let's make sure we're keeping all three of these things in mind when we're evaluating the impacts that BMP could have on our project. Next, we'll kind of get into just high-level discussions on quantity and quality. So we certainly want to acknowledge the fact that traditional BMPs are still at play, and they may be the best path for your project. But this presentation, we're really just going to focus in on those innovative applications. And when we take into consideration these innovative applications from a quantity standpoint, we're really looking at ways to reduce our volume runoff, reduce the flow of that runoff, and then looking at changing the flow regime through some kind of sheet flow application. From a quality standpoint, we can purchase credits. Some localities and some state DOTs would require the purchase of credits. Sometimes it certainly it could be a cheaper option. And one of the benefits of credits is it does kind of relieve whoever's maintaining, a BMP facility, it relieves them of that maintenance burden. So again, credits are certainly an option that you can take for quality. But we also want to recognize that there may be larger projects that require you to treat quality on site, or you may be in a jurisdiction that doesn't allow the purchase of credits. So again, the BMP solutions that we look at today, some of them do have quality components, and we'll certainly let you know those BMPs that address that. Coming up, we'll kind of be diving into some of the technical criteria on some of these BMP solutions for linear projects. We're going to be talking at a high level, kind of general terms, but I wanted to stress the importance and knowing your local regulations, knowing what they will allow, and really getting the feedback and buy-in from your jurisdiction before making a recommendation on any of these solutions for your projects. And with that, I'll turn it over to Mike Claude.
Thanks, Craig. So we'd like to distinguish the BMPs that serve both quality and quantity as what we call runoff reduction BMPs. This distinction kind of speaks to the benefits that they serve, especially when you're looking to meet an energy balance component or a runoff component for your site. You normally wouldn't consider a quality only BMP if you're looking to do these type of functions. So one of the first one I'm going to look at is what we call soil compost amendments. Soil compost amendments are effectively serve to increase the infiltration rate and decrease the stormwater runoff. Typically, this can be viewed as going from, say, a D-type soil to a C or a B-type soil. This is a soil restoration practice. Typically involves tilling in with new soils into deeply compacted soils and amendments into them. It helps to restore the porosity, amends them with some compost, and you can see on the right-hand side of the slide that there are some different types of compost that you can use for this application. Again, these soil amendments can reduce the generation of runoff from compacted urban lawns and impervious stormwater runoff from roads and other features. Typically, this practice is not something we would recommend if you have a highly infiltrating soils on your site already, or steep slopes that would exceed, say, a 10% grade or greater than that. Soil areas that would be naturally or seasonally wet. Anything that would drain really to a building or a foundation that could cause issues for a structure. Next slide. So they provide a stormwater function for both water quality and quantity. Again, these can be used in conjunction with filter strips and grass channels to help reduce runoff reduction capabilities. They do provide a moderate stormwater reduction for the quantity of water that flows across them. And they will also provide some low to moderate quality production or reductions as well. The minor long-term maintenance of these, I guess the long-term maintenance is kind of minor associated with these. In some areas, we found that the compost amendments sometimes need to be recorded as a BMP and could be, needed to be in accordance with schedules according to the MS4 permit. Generally would not need a maintenance agreement. Like I said, they're not really high maintenance applications. One project that I'd like to speak to that we use these projects on or tried to incorporate these functions was our Jefferson Avenue project. This was located in the city of Richmond, Virginia. As you can see from the top right graphic, there's a large drainage area that's outlined in blue. This is kind of the service area for this corridor. Again, this is within the city limits, so it's a lot of highly impervious area with parking lots, with roads, with building structures. Any of the grassed areas that you see, a lot of these are lawn areas or gravel areas and things like that. So with this project, we were looking to do enhancements along the Jefferson Avenue corridor, which is outlined in red for the street corridor. Looking to use some green infrastructure to help reduce the stormwater pollution and downstream flooding in these areas. Obviously improve the corridor appearance with some community green spaces. Reduce the perception of, cut through routes in here. And a lot of the things that we were trying to achieve with the stormwater on this was a reduction in the volume of discharge that comes to this area. There's a combined sewer system for this section of the downtown area, and that systems tend to get overwhelmed. So anytime we can provide a way to reduce the amount of runoff that comes to those systems directly through the storm sewer or direct runoff, this helps to provide us this additional capacity for the system. So you can see with some of the pictures that are associated here, we were looking to have a 10-10 detention of any increased peak discharges. And those grassed areas that you see were put in there to increase the green space. And also the mulch beds and the bump outs in the drive aisles were to help kind of reduce the impervious area and provide grass and or compost areas to collect stormwater runoff prior to it getting into the system, where it would actually have a chance to infiltrate some and slow that water down. The next practice we'd like to look at is permeable pavement. So permeable pavement provides a function for both water quality and quantity. So you do get the runoff reduction benefit. They are alternative paving surfaces to traditional asphalt. These surfaces will allow the stormwater runoff to filter through the voids within the pavement and into the underlying stone reservoirs. That can be stored there temporarily, or you can do areas where you can actually have the water be stored, and if you have infiltrating soils, it can be infiltrated into the area below that. There's a lot of different applications with pavers and or porous asphalt or permeable concrete. There's a variety of different ways that you can configure this. But some of the benefits of this, they can obviously provide some water quality and quantity benefit, as well as they can provide a channel protection and flood mitigation benefit. These can help to reduce the curb number and adjust for larger storm events based on overall retention provided. You can also provide for extra storage in the stone layer underneath the main pavement layer, and these will actually allow for peak control structure to accommodate larger detention of larger storm flows. In addition to the typical requirements, again, you can provide some additional flood mitigation with these because you may be able to design additional storage in the reservoir layer by adding a perforated storage pipe or chamber. In some cases, the reservoir required to serve the load-bearing functions of the road systems or traffic or parking would exceed the stormwater volume requirements. So these BMPs can be very beneficial in mitigating flood control on larger storm events. They are very cost effective. Some recent published data has shown that, especially for new construction, permeable pavers specifically are highly cost competitive with traditional pavement. Plus they help separate with, provide stormwater management. These can be somewhat, I think a misnomer is they can become kind of intimidating from a maintenance perspective. But if they're regularly maintained, they can actually be very cost effective. Again, the typical use is a vac truck to go in and to clean these areas out. Some of the things that you would want to avoid when you're dealing with pavers is a sanding or resealing and or resurfacing of the area where the pavers have been applied. You would want to avoid storage of snow piles that would contain sand if possible, storage of any mulch or soil materials. And you want to kind of limit the use of these areas for construction staging unless you're providing some sort of protection between whatever the equipment that you're storing there. For linear projects, these are very adaptable to city streets, parking lots, and residential road use. Can be done in multiple configurations. They provide for a good benefit for urban streetscape projects and working within a constrained right-of-way. Two of the projects that we wanted to look at associated with this were located within the town of Ashland. The first is this pave drain project. This was a local residential street, and this street has a lot of direct runoff from the lawns and other areas around it that would run into the road or run into low areas. There's very little topographic relief, so a lot of times there's standing water. The town chose to use this pave drain system because the blocks that are associated with this, as you can see, have a hollowed out bottom, so they will actually provide some additional storage within the stone section itself that will reduce your amount of the gravel that you have to put underneath it from a reservoir layer. So that was one of the benefits that they used there. This helped them to capture the runoff in this area and store it underneath the road, as well as it got rid of a lot of the issues with the standing water that they've had out there. The second project is really kind of various areas around the town. These are parking lots within the town area that they've done. The one in the top right is associated with their police department. That was a traditional paved parking lot area. And the drainage area to the pipe that you see there that comes out into the stream channel is about 50 to 60 acres or so of untreated, highly impervious area within the town. So what they were looking to do was this partial stream restoration that you see below, but in association with that, we were trying to get some additional water quality benefit for the adjacent site. So we converted the parking lot to permeable pavers and provided a storage layer there as well to hold the water in, and it discharges to the stream channel. Again, what we're using there in other areas around the town are looking at parking lots for shopping and things like that, where they allow people to come in and they can park in a general location and then walk around the town for shopping. Whenever installing the new pavement, especially the parking lot areas, we like to look at utilizing permeable pavement whenever possible. It's not only great for compliance, you can see where they've also incorporated some of these rain gardens and things like that in the areas adjacent to the parking lot, so that the permeable pavement will drain to those areas to provide additional treatment. But they also decrease the amount of hot or fast water that would run off from the parking lots to impervious areas. So again, you can get a dual benefit from that because it keeps the cooler waters running off to the stream systems. The next system we'd like to look at is the modifications to standard structures. These are mainly used for water quantity projects within limited right-of-way. These are looking at using traditional system components to manage the peak discharge and offset increases in the volume of runoff. Typically, they would use a manhole structure or a junction box structure and incorporate a weir or orifice within the structure to help regulate the water, discharges, and use of an oversized pipe to store the water behind it. Mainly, a lot of localities are interested in what we're seeing installing these within the right-of-way. Some of them don't like to have above ground BMPs traditionally within the right-of-way, so they're looking for alternative solutions. For these, for like permeable sidewalks, instead of permeable sidewalks, I mean. So we're using these for a lot of smaller footprint BMPs. Some of the filters and cartridge stuff don't really provide the runoff reduction, and they only really are related for quality only. So this may be the only option to reduce the runoff of volume and to design the oversized storage area. These can be the outlet control structures that are capable of managing both the 1-year and the 10-year storm event. Water quality sometimes is possible with these systems, but typically would require an inline cartridge or filtration system. And also load reductions for these applications are typically low. When we do these projects, generally sidewalk and lane widening, so most of the time, a lot of the purchasing of credits is done for the water quality aspect. Maintenance is generally fairly easy with these, can be performed with the vac truck as necessary. Generally consists of cleaning out debris and trash from the inlet structures around the weir and orifice to ensure the clogging doesn't occur. For linear projects, again, these are adaptable to street environments in the cities, parking lots, again, and residential road use. They're available to do in multiple configurations for urban streetscape projects. Once again, they work in shallow and or deep installations and can also fit usually within a constrained right-of-way. Again, from a quantity perspective, they provide a high stormwater reduction. From a quality perspective, it's very low, and you would have to implement, again, a cartridge type system to do that. The example project we have here is the Wistar Road project. This one was done for a streetscape project with the sidewalk improvements. It had 7 distinct drainage points of analysis, 3 of those which required underground detention systems. As you can see in the top picture on the CAD drawing, one of those systems utilized a double run of pipe to provide the storage. And then within the inlet structure, the junction box, we created this weir with an orifice that you can see in the pictures on the bottom to allow for the water to be held back and stored within those pipes and dissipated at pre-developed rates. The last system I'd like to look at is the modular wetland system. There are a lot of proprietary options approved for many state DEQs, through their clearinghouses if your project is just looking to have a water quality component. For instance, if you don't have a natural channel within your limits of analysis, or your downstream man-made system is more than adequate to handle your improvements, this would be a situation where you would want to look at some of these quality BMPs. Due to space constraints, proprietary devices become very appealing. One example is this modular wetland system. Its components generally consist of a pre-treatment, which can be a debris collection in pre-filter boxes, the bioretention media that you see in the middle, and then some sort of a discharge, potentially a flow control device as well. Pollutant removal is generally similar to a bioretention system. And again, a lot of these are approved by the DEQs for the local states. And as far as the treatment goes, it would vary depending upon the state. From a maintenance aspect, they can be moderate to intensive depending upon the type of system. You can see here there's different modifications for those systems. When you place them in, you can have a curb type system, a grate type system, or vault type. For linear applications, they are adaptable to street use and parking lots and some residential areas. Can be done in multiple configurations, and they work with shallow or deep installation and standalone applications. These again can be moderate to intensive for maintenance, but some filters also providing the pre-treatment systems will help with that system, with maintenance cost. And with that, I'm going to turn it over to Brian to talk more about some other features.
Thank you, Mike. Again, I'm Brian Copeland, and I'm going to talk to you first about the Silva cell suspended pavement system. This is a product that was manufactured or is manufactured by Deep Root Grain Infrastructure, was created as a way to promote root growth in urban areas where there's tightly compacted soil, but was also adapted to provide on-site stormwater management treatment. These consist of vertical structural columns. You can see there in the lower left-hand corner that would essentially suspend the pavement or the sidewalk above and allow for uncompacted or less compacted soil to be placed beneath it, mostly for the growth of trees or to promote tree growth in urban areas, but also to provide stormwater filtering towards a project's stormwater management goals. The heights come in 3 different heights, range from 16 inches to 36 inches, and the selection of which ones to use is based on the amount of soil volume that you need for a particular tree or the amount of treatment volume you need to satisfy some of your water quality or quantity goals. Water delivery and pre-treatment are critical in this. Usually used in urban settings with traditional storm sewer systems where you'd have an advanced pre-treatment catch basin where the first flush of drainage would run into the catch basin, filter out any of the large debris, and then be distributed to the system. You can also incorporate open tree wells with curb cuts. You can kind of see it up there in the top picture where water would flow in through a grate system and then down through the media from that point. You can also incorporate permeable pavement or permeable concrete above that will allow water just to infiltrate straight into the top of the uncompacted soil media. Or you can actually direct roof drain runoff in urban areas directly into the top of these systems. You can see there in both of the exhibits, there's what I like to call a reverse underdrain or a distribution pipe where water will will be distributed evenly along the top of these structures, then percolate down through the filter media, and then ultimately down to an under drain at the bottom there. It's important with these that you have multiple clean out points of access. A lot of these you can see in the lower diagram where you can actually place the clean out flush with the concrete slab below pavers so that they're hidden. Another optional feature to this shown in the bottom is a internal water storage zone. So during times of drought, or when there's not a lot of rainfall during the summer and there's not a lot of irrigation going on, you can allow for a space for water to be held so that the root systems above have an opportunity to get the roots to some of those locations. It has a pretty high quality benefit, generally about the same as bioretention basins. It does also provide some quantity benefit as well, reducing the volume of runoff through the void ratio of the media and the space above. And this product is currently approved by both the Virginia and North Carolina DEQ. So typical roadway applications for this, obviously, in speaking towards the urban streetscape projects, important to be traffic rated. They are H20 loaded and can receive traffic loads. My recommendation is to use it more in a sidewalk application where the traffic load may be occasional only, but ideal for locations where there's constrained right-of-way, densely compacted soil, as I mentioned, and where you're looking for an opportunity to promote tree health and longevity as part of your streetscape projects. Some things to keep in mind on that, however, obviously urban environments have a lot of signs, vertical penetrations to the sidewalk, light posts, things like that. These are pretty agile units, so they can be really put into any configuration in the ground as long as they're no further away than a minimum distance apart to provide the required loading. Also, ideal for storm sewer system integration. And like I mentioned earlier about the pre-treatment need, it also provides for the ability of larger storms to overflow the pre-treatment catch basin into the more traditional systems, and also will allow for an opportunity to daylight the under drain below, which would be required in more dense urban settings. This can be installed on grade, so if you have a longitudinal grade on a road of up to 5%, you don't have to stair step them. They maintain their structural loading on a slope of up to 5%, so they don't need to be stair stepped. Obviously, for inside the right-of-way applications where right-of-way is either really expensive or there's building constraints. So although this is a relatively costly application, it can be easily offset by locations outside the right-of-way where the cost would be extraordinarily high or impossible because of buildings. These do play fairly well with utilities. You can see pictured in the pictures in the middle some existing flexible private utility conduit being installed through the Silva cell units that would just be backfilled with loosely compacted engineered media. Important to consider future planning of utilities and installing spare conduit to the extent that is reasonable. Reason for that is once it's in the Silva cell units, it's pretty difficult to get those conduit out. I highly recommend in some of those urban settings is to get lots of test pits, test holes on the utility information that you have to discover whether or not those utilities are encased in concrete, which can quite often be the case. And Silva cells obviously would not play well with any concrete in the ground. One thing that you can kind of see in the bottom two pictures are perpendicular penetrations to the Silva cell unit for public services. One of the options that you can use are options to span the Silva cell structurally. The lower right-hand corner picture shows kind of precast concrete slabs that can be basically just lifted and removed by a backhoe to get to an underlying water or gas service that may need to go between where access to that may be limited if it runs through the Silva cell. So that's another option there. They do come with maintenance challenges. So pre-treatment and the location of cleanouts are critical. Essentially, once the removal of the filter media, if they become clogged, become problematic. So just make sure that any jurisdiction that you may be installing these in is willing to accept the maintenance aspects that may come with this. This is a project, West Main Street, located in the city of Charlottesville. Again, a very dense urban setting. This is a location, it's about a 1 mile reconfiguration of a roadway that connects the downtown mall with the University of Virginia. This is a project where it was recommended that we treat all of our stormwater on site. That obviously comes with challenges in urban settings with competing uses. So if you have pedestrian space that you're trying to maintain, another option to look at is open urban bioretention. The problem with those applications is that it pretty much eliminates that from the ability to use it also as a pedestrian space. So having the ability to suspend the sidewalk and maximize the amount of pedestrian space you have within a limited right-of-way is one of the overarching benefits of using this type of system. This project is currently in design development, so that you can kind of see what it would look like in a cutaway view in the lower left-hand corner. And this is a practice. The project was actually used to show how you can demonstrate stormwater compliance as part of Deep Roots Virginia DEQ approval of this product. Moving on to the next BMP, dry and wet swales. These are pretty well used in more of the rural typical section projects. If you're using a ditch and when you convert that ditch or shoulder and ditch section to trapezoidal ditch section, those slopes, longitudinal slopes, are ideal at 0.5% up to 4%. These structures you can kind of see in the typical sections on the right. They have different weir structures. You can use rock check dams, timbered weir notch weirs, like you can see in the right-hand corner. You can also use earthen berm structures with a small relief pipe. Drew and we'll share an example of that with some micro ponds coming up. Dry swales, also called bioswales, you might hear that term around. Those are typically just used grass vegetation. The picture above, you can see, has about 24 inches of filtered engineered soil mix, followed by a choker stone layer that will prevent some of the fines from migrating down to the clean aggregate layer of stone below that will also house the under drain with cleanouts. The wet swale sometimes can get confused with dry swales, but the wet swale is another type of BMP. Two main differences with the wet swale in this case. One, it does not have the filter media component to it, which does result in a slightly less removal efficiency for treating water quality on site. It also incorporates wetland plants, sometimes with shallow pools, but is essentially like an aquatic bench for a BMP, but the aquatic bench will help to provide a little bit better runoff reduction as part of their stormwater goals. And like I mentioned, dry swales, kind of like bioretention, will have a high pollutant removal rate, a little bit more than wet swales. Typical roadway applications for this. It's a good alternative to bulky ponds. So if you have a project that you're looking at an outfall and whether a large pond would fit that instance, this might be another thing to look at. It has various applications. You can either just use it for detention, so no underlying improvements, just make it a wide grass ditch and put weirs in to provide some detention. You can convert those pretty easily to dry swales that, like I mentioned, has a higher removal efficiency. Wet swales, more ideal for locations where there may be a high groundwater table, like in coastal areas. For that application, it all just depends on the project and what your on-site quality removal needs may be. It's good for rural typical sections from the perspective of if you have a shoulder and you have a forest slope going into the ditch, it already has that natural pre-treatment kind of built into it. Good for depressed medians, wider depressed medians, also good for treatment drains. So if you've got a pond on the project, not quite getting what you need, you can look at maybe the last 200 or 300 feet of your ditch leading to that pond, widen it out, and turn that into a dry swale. Like I mentioned, it's ideal for flat grades. It can be up to 4%, but flatter grades are more ideal for infiltration. You also want to make sure whenever you're applying this, particularly on the dry swale side, if you have an underdrain, is to make sure you have enough relief to daylight that. And then you can see in the picture at the bottom, it's good to distribute that flow. So in the case of the project I'll get to next, there was some drainage on the other side of the road that was not ideal for widening for a trapezoidal ditch because of utilities. So we introduced multiple lines of culvert that would intermittently introduce drainage from one side of the road to the other to get the maximum amount of treatment out of the side of the road that was more ideal for this application. Utility considerations. One of the things to consider is when you start talking with utilities, make sure you've done enough design of these to know how wide it's going to be. So when they start doing their design, they start figuring out how much easement that they may need. You've done enough design to know hydraulically that this needs to be a 5-foot, 6-foot, 8-foot, 12-foot wide trapezoidal ditch so that they know where they need to be. Also in roadway settings, compaction is a big deal, making sure you get high levels of compaction, particularly under the pavement section. But in doing so, you want to make sure that you're not overly compacting some of the areas that you want to infiltrate in some of the areas here, particularly if you're using a dry swale application where you're using filter media. This is the project that was that picture in the last slide. This is a 1 mile, 4-lane divided widening in Hanover County, Virginia. The project is currently under construction, but as we started to look at some of the stormwater goals for this, we first started looking at ponds and where those could be best located at some of the downstream channels. And due to some environmental and potential impacts to the potential developable potential for some of the properties, a large pond would impact, we looked at, well, what if we kind of redistributed some of that volume along the frontage of the road so that we weren't hitting one property more than any of the other ones. This project, we did decide to purchase offsite nutrients, so we were just looking at addressing the quantity side of things. So we provided enough detention behind the weirs in the trapezoidal ditch on the way to the outfall channel to provide the necessary detention to meet the quantity requirements. One of the things you do want to make sure of when you're looking at these is when you do have those weirs and you're placing them inside the clear zone for your roadways, that you're providing a traversable surface, 6-to-1 wedge in front of anything that may be considered a fixed object, like timber weirs or kind of vertical structures. Another interesting component of this project was that there are a lot of utilities in the road that didn't want to move quite so far out away from the road on the backside of the swale. So we worked collectively with 3 of those utilities to do a joint build with one contractor to install all of the conduit at a deep enough depth not to be impacted inside the right-of-way in the shoulder, so that when they came through inside the right-of-way, we were able to come through, construct our shoulders, cut down to grade, and have them not be impacted, but also not thrown to the backside of the ditch. So it kind of worked out as good as it could for everyone on this. Last BMP I want to talk about is roadside bioretention. So very, very similar to the wet swale application, the dry swale application is linear bioretention. So the biggest difference here is it's basically constructed at a 0% grade over the length of the channel. It still has a 6 inches of ponding. You still want to have the filter media and the choker stone. More times than not, particularly in areas of high groundwater, you'll want to have an underdrain with cleanouts that will be able to daylight to some surrounding storm sewer systems. There are some things with this that you can do to enhance some of the pollutant removal efficiencies. You can increase the depth of the filter media. You can also apply some additional plantings within the flat footprint. You can increase the sump below the underdrain. So kind of the dark tan area in the section on the upper right-hand corner that shows kind of a deeper area of stone. You can also increase the length to width area of the flow path. That'll also get you some increased efficiency. It does provide for stormwater runoff reduction on the quantity side, so you actually remove the volume of runoff towards that goal. But this the picture in the lower left-hand corner is a project I'll show some more pictures of here in a minute, but that's kind of an in-place application of a linear bioretention installed inside of a depressed medium. Typical applications for this type, obviously, relatively small drainage areas. You want to put them in locations where you can receive surface flows. So once drainage has gotten into a traditional storm sewer system where it may be concentrated deep in the ground, then at that point it's not ideal to introduce these. You want to have these where water can sheet flow in, or you have curb cuts that will be able to take surface flow directly into the top of it. For planning purposes, generally these would be in the neighborhood of 3% to 6% of the drainage area size, just for footprint size. Ideal for roadways from the perspective of if you have irregularly shaped rights of way, some utility conflicts, these can be configured in any shape, so that if you have residual right of way, campered off a corner in the corner of an intersection, where linear application doesn't work best, it doesn't fit as well as an irregular shaped basin would, this is a good application. It also provides an opportunity. There's not a lot of fixed objects in these. So these are ideal in the clear zone, off the roadway. If there are any concrete structures or fixed structures, you can put a 6-to-1 stone wedge around it, but they're generally considered free of fixed objects. You can use them on some of those roadway applications. They can be used in urban streetscape opportunities, using curb cuts from the roadway. These generally can be more expensive because they usually will require some concrete chambers for some of that open bioretention. But like I had mentioned before, in rural settings, suburban settings, you have shoulder and ditch sections. Those can be more ideal applications. Also on trail projects, similar to the project in the lower right-hand corner, where they're generally built through open space, they allow for a good surface flow, and these are generally locations where you want to have some level of beautification with landscaping, but it fits well into that environment. This project is a project in the city of Stanton that was completed about 5 years ago, just off of I-81. This project was intended to promote access to future commercial business prospects. Basically was a quarter-mile, 4-lane divided road with a roundabout and a lot of points of entrance access. For this project, there is a city ordinance that required the use of on-site LID to meet the stormwater management goals for this project. So being that it was more of an urban curb and gutter type of road, we looked at, how would we best implement this? And here are pictures taken, these were actually taken 5 years later. You can see we have drainage draining through curb cuts with stone pre-treatment into the bioretention. Some of the larger storms, you can see the inlets in the lower left-hand corner that were placed downstream of each one of the curb cuts to receive drainage from larger storms, but also has under drain that would come over and daylight into that once water had a chance to filter down. So a good roadway application here. Another application that was constructed in the city of Hampton, the Hampton Roads Center Parkway project. This was a beautification project constructed with through a NIFWIP grant, and was intended to towards meeting the city's water quality credit and city's TMDL goals. This project actually was a quick hitter, but from the time we got notice to proceed in October of 17, project was completed in December of 17. So just 2 months from notice to proceed to finish, using the city's on-call contractor. Although this one was more of a retrofit project, this one could easily have been implemented, or can easily be implemented as part of a more traditional roadway improvement project to meet some of the specific goals that they have for those projects. And with that, I'm going to go ahead and turn it over to Drew Sullivan to talk about a few more BMPs and strategies.
Thanks, Brian. First up for me that I want to discuss is modular water quality treatment devices. And most of you have probably seen these before. I feel like they're fairly common in this area. The way they work is stormwater runoff enters through a curb opening and flows through a special design filter media. The filter media retains the pollutants which are decomposed and used by whatever planting is in the box, shrub or tree. Then the stormwater flows to the bottom of the box into an underdrain system where it's discharged. They differ from the modular wetlands that were discussed earlier in that they take up less space, and they can be partially traversable by pedestrians. So you can have them up on the curb with your sidewalk on the back and still have people walk over them. Modular wetland systems, they have multiple plantings instead of just one. They have more of a marshy feel. So I feel like these inlets are style are a little bit better applied to roadway projects. And they differ from Silva cells that we discussed in that there's no detention component to these. This slide, same result, just a different sort of mechanism to achieve it. The filtering is accomplished through membranes or sand media. You can see the top picture and the one on the left are a vault structure. The one on the bottom right is a membrane that it's a jellyfish that is used in a manhole structure. So you can use both kind of configurations. The sizes vary. You can see on the top image there, that's a perk filter. It has on the left side a debris separator or a sedimentation chamber, so all that junk doesn't flow into those membranes filters to the right side. And just for reference, the one on the bottom left is an upflow. That one's one that uses sand or media bags and those blue components there. And then you'll also see on the slide, I just listed a bunch that you may have heard of before that do more or less the same thing. On roadway projects, you'll typically see these sorts of devices placed next to standard drop inlets. They're relatively expensive for the treatment they provide, but that cost to benefit ratio will vary based on how much removal credit they get, which varies by state. You want to place them in drainage areas with as little off-site flow coming to them as possible and with as much project impervious area as possible. And that just maximizes the amount of phosphorus and nitrogen removal credits that you'll achieve. Like I said previously, they do collect trash and debris, which lowers the efficiency. So they need to be, that debris and sediment needs to be removed via a vac truck usually. The ones that do have the filter cartridges or membranes, they need to be cleaned and then eventually replaced. And that'll just vary how often that needs to occur for each unit. They do have a much smaller footprint than traditional BMPs, which make them a great option for projects with tight right-of-way constraints. For implementation, these were used on the Woolridge Road widening over the Swift Creek Reservoir in Chesterfield County. The reason why is the reservoir supplies drinking water to much of the county, and because of that, on-site water quality treatment is required for anything that drains to the reservoir. Moving on to the next one, level spreaders and filter strips. This is a practice that converts concentrated flow back to sheet flow and then infiltrates it across a flat area. It consists of a forebay or an energy dissipator, which just slows down the inflow to prevent erosion or settle out sediment. Flow then moves into a swale or a ditch, which has no longitudinal grade, so it's essentially a holding area for water to pond until it spills over the level spreader lip. And then after it does spill over, that shallow sheet flow will infiltrate over a wide grass filter strip. In this slide, the image from the left is North Carolina's standard, and image on the right is Virginia. Both of these very similar and accomplishing the same thing. A flow splitter might be required in situations where your incoming flow is too large for a level spreader to handle, or in a situation where you don't want your level spreader lip to be huge or too long. It's just your site constraints won't allow it. The level spreader lip itself can be constructed from many different materials. I've seen concrete beams used, concrete curbs, wooden timbers, or just grass with reinforcement matting. The best location for these in conjunction with filter strips is next to a natural waterway. If you're maybe think of a stream with shallow slopes leading down towards it, with the idea being to sheet flow your project runoff and allow it to infiltrate at least partially before it gets to the waterway instead of dumping it directly into the waterway as a point source. And the idea is to prevent stream channel erosion. It is possible to place your level spreader lip parallel to the roadway, which will keep things as close to the road as possible. Another consideration is if your filter strip need is wider than the minimum, meaning it was pushing it farther away from the roadway, you can increase your level spreader length to keep that width down. The slope of the filter strip needs to be constant to prevent channelization and allow water to infiltrate. This has very low maintenance costs compared to some others that we've talked about. The construction of the level lip is critical to the function because if it's not level, water is going to channelize when spilling over. It has low construction and materials costs as well. The main concern with this will be the space that the filter strip takes up. And you can also use the compost amended soils that Mike was talking about at the beginning for this filter strip, which North Carolina actually does recommend using in this instance to promote plant growth. Next, I will be discussing some stormwater strategies, stormwater management strategies, which aren't BMPs, but there's some things we've learned and implemented over the years to get the most out of our stormwater management designs. And this picture is from Atlee Road in Hanover County. The first strategy I'll discuss is a follow-up on the last BMP, which is sheet flow. In Virginia, sheet flow is often accepted as an adequate form of quantity attenuation if there's no downstream erosion, sedimentation, or flooding. And it's also important to remember, instead of channelizing, if you don't need to, instead of using curb and gutter or shoulder and ditch, you might just try to sheet flow directly off the shoulder with no ditch. Some additional things I've seen in regards to this practice, it's reviewer or locality dependent. Some will accept it and some don't. I wouldn't try to use it at an outfall where it's obvious water naturally channelizes just off site. For level spreaders with filter strips, and this is just my experience, I've done modified rational method with the 1-inch storm for level spreaders without filter strips, provided the 1-inch storm calculation and weir calculations using the 2 and 10-year storms, and I'll show how long the level spreader needs to be for 1 inch, 2 inch, and 3 inches of flow depth over the lip for 2 and 10, and then just use engineering judgment to choose a level spreader length. Here's a couple projects we've used level spreaders on. They're both in Chesterfield County. Take note of the different level lip construction materials and techniques. The top one is Old 100 Elementary School, which uses a wooden timber. At the bottom is concrete lip with wire mesh wrapping, and that's on Hicks Road in Chesterfield as well. Craig touched on this at the beginning, but I wanted to briefly touch on it again through kind of a case study to demonstrate why it's important. Knowing which activities are exempt from the regulations of whichever jurisdiction you're in and using it to optimize your design. So this brief little case study, I'll call it, is the image on this slide is VDOT guidance on which portions of a roadway project are exempt from the regulations. Anything that's exempt can be omitted from your project disturbed area. And generally speaking, keeping that project disturbed area smaller is going to help you. But what it shows is that milling and overlay and travel lane or shoulder reconstruction are exempt. So you can just omit those from your disturbed area. And it's important to note that it can be the same project. You can have mill and overlay next to reconstruction, next to new pavement, and the new pavement will apply, and the other stuff won't. Same project, same road. Again, this is just a VDOT example for what they accept. So check the code of your project's jurisdiction to see how you can optimize your design with whatever regulations you're working with. Next strategy, we're calling outfall management, which essentially is robbing drainage area from one outfall and sending it to another. You would want to do this in situations where it's extremely difficult to meet water quantity attenuation due to cost or lack of space. So in this image on the slide, this concept is illustrated by taking some of outfall 2's drainage area, which is the one on the right, and sending it to outfall 1, and that's that red hatched area you see in the middle. Outfall 2 would then meet water quantity requirements by having less of a peak flow from that reduced drainage area coming to it, where you would then require or put some sort of BMP in outfall 1. A couple situations where you can easily implement this is in median ditches where there's a local high point. You can just simply shift the high point of the ditch line. Another is using drop inlets on one side of a high point to pipe water back to the other side. And lastly, micro ponds. There are several small ponds that are created by using berms and a ditch, and also in place of berms, you can use the wooden timbers with orifice at the bottom if you're not in clear zone. But for this berm application, there's an orifice or pipe at the ditch invert, so larger storms will just pass over top of the berm. The goal is to reduce peak flows through repeated detention behind the berms. They're typically used in shoulder and ditch sections where offsite runoff can't be separated from roadway runoff. And you might be wondering, why not just use a dry swale? But dry swales are typically used when nutrient credit purchase is not an option. They're more expensive and they require more maintenance. These micro ponds are typically used when you are able to purchase credits, but just need to meet water quantity requirements. They can be designed close to the road to minimize your right-of-way needs. For instance, an existing ditch can just be modified or retrofit with these. If you need more detention, you can turn a V-ditch into flat bottom to gain more detention. And that is it for me. Thanks, guys.
Thanks, Drew. So you may be asking yourself how certain BMPs stack up against others. So we've generated a slide that it doesn't go through every BMP that was discussed today, but it touches on a few of them. So we wanted everyone to kind of see some of the impacts as far as cost and maintenance, and see what kind of benefits you get from quality and quantity. I did want to point out that you may have a site-specific constraint where you want to use something that has not only a high cost, but also you get a high quality from. For instance, if you have limited right-of-way, you may want to use a more expensive modular water quality device like a Filterra or a Jellyfish. Outside of the ones that are on this slide, I did want to just highlight the fact that Drew went over some really great strategies. Oftentimes the strategy part of it is where you can save a lot of money on your projects and potentially save on some schedules. So certainly look to those strategies as well as some of these BMP treatments. We certainly have a lot of folks from a lot of jurisdictions and DOTs across multiple states. So we wanted to take this opportunity to just thank everybody for trusting Timmons Group with your projects. We do have our contact information here. So without hesitation, please send us your questions if you have any. We'd be more than happy to talk about any services, stormwater or otherwise, with you on your projects. And I know we did get a few questions and we have a couple minutes, so I will go ahead and get into those. Jill asked, have you used a modular wetland or deep root systems in areas with a high water table? What is the depth for the under drains? Brian Copeland, I will let you run with that one.
I've never used the modular wetlands on a project before, but in terms of the deep root systems or the Silva cell systems with under drain, for really anything that we have under drain, generally speaking, the under drain will be between 3 and 4 feet in the ground once you consider some of the different layers of information, the storage above, the filter media, the clean gravel below. So in terms of under drain, which that 4 feet generally aligns with kind of your minimum depth for a storm sewer system anyway. So that's kind of the general depth requirement that we've seen. But I would imagine the same would be true in terms of the depth of the modular wetland systems that have some of their outflow structures that they need to implement as well, tying to storm drain systems.
Perfect, thanks, Brian. We got a question from David. Have you used floating island BMPs in existing wet ponds? I know that, I believe those are called floating treatment wetlands too. While I personally don't have any experience in utilizing those on a project, I know they can be used as retrofit projects for existing wet ponds. Mike, I'll ask you if you have any experience in that, and if not, that's something we can certainly get back to David on.
Yeah, thanks, Greg. We've seen a couple of applications of that where people have used the similar to like the modular systems, where it'll be kind of like a modular platform that'll put out there with a bioretention media, if you will, or some sort of media with vegetation plantings that will provide additional uptake of nutrients. So I've seen them on a couple of golf courses, and I've seen them on some private lakes and things like that. I don't have a lot of experience with those, to be honest with you, as far as implementation of them, but I know that they will provide some additional nutrient uptake in those environments.
Thank you, Mike. Brittany, I believe that's all the time we have today. Do you have any closing comments?
Thank you everyone for joining us today. As Craig said, please feel free to call or email today's presenters with any additional questions that you might have. We will be sending out certificates of completion to everyone who attended today. And this presentation was recorded and it will be uploaded on the Timmins Group YouTube page. So if you are interested in watching it again or wanting it to send to anyone of any of your colleagues, please feel free to do that as well. And with that, that concludes our online program. Thank you again to our presenters and all of today's participants.